What is the greenhouse effect? So, what is the greenhouse effect? We have a nice graphic which illustrates this nicely. However, there are mistakes and I will point them out to you. The greenhouse effect has a big impact on the temperature of the Earth. Stage 1. Radiation from the Sun in the form of light waves in all parts of the spectrum enter the atmosphere, and these are absorbed by the Earth and they warm up the Earth. So we know that when an object absorbs radiation from the Sun, it warms up. Now, when the Earth warms up, it will start to radiate more radiation because it gets hotter. The radiation which is emitted will be infrared radiation. It's in this part of the spectrum that warm objects radiate light. It will be infrared. And some of this heat travels back through the atmosphere and escapes into outer space. So, to recap, all the different radiations come into the Earth, hit the Earth's surface, some are absorbed, the Earth heats up slightly and re-emits in the infrared part of the spectrum. Now, the problem is that some of this radiation in the infrared is basically absorbed by the chemicals in the atmosphere, by the carbon dioxide, water, methane and so on. Once they're absorbed, then they are re-emitted. Some of it goes back to Earth, some of it goes back into space, but some of it gets re-emitted back into Earth. What it says here is that some of the energy is absorbed by the greenhouse gases, correct, in the atmosphere, and so is reflected. Reflected is not the verb, it is not the process of reflection. It is absorbed and re-emitted back to Earth. But this part is correct. This causes the temperature of the Earth to rise. Now, as increased levels of greenhouse gases in the atmosphere trap more of the emitted infrared, the emitted heat, more it's going to be re-emitted back to Earth, causing an increase in the radiation. Now, you might ask a question. Why is it that this radiation which comes in the first place is not absorbed by the gases in the atmosphere and re-emitted back into space? The light that comes from the sun is in all parts of the spectrum, the blue, the ultraviolet and the visible part of the spectrum, and the atmosphere is transparent to these wavelengths, so the carbon dioxide and the water, these radiations pass through them. However, infrared is a very particular frequency which will be absorbed by these gases, and therefore these are the ones, it's only in the infrared that it gets re-emitted back to here. Some light will of course be reflected, but all of this radiation, most of this radiation will get through the atmosphere. When it's in the infrared, it doesn't manage to pass through because the frequency has changed. We have to identify the main greenhouse gases and their sources. The greenhouse gases are considered to be CH4, methane, H2O, CO2 and N2O. Now, when the gas is H2O, what are the natural sources of that evaporation? Man-made sources, there are some, but and this is a greenhouse gas. Water is a greenhouse gas. Next one is carbon dioxide. This happens naturally due to forest fires, volcanic eruption, and from oceans. There's some gas given from oceans, but also mankind makes a great deal of CO2 from burning fossil fuels, from cars, and from burning things generally. Methane, CH4, this is emitted by wetlands, by oceans, by lakes and rivers, but also due to man's activity. When we flood rice fields, this produces CH4. When we farm animals, cows, they produce a lot of methane. Termites, the processing of coal, and the burning of biomass, this also produces methane. So man contributes to the amount of methane in the atmosphere. N2O, that comes from forests, oceans, soils and grasslands, naturally. But also man makes this by burning fossil fuels, manufacturing of cement, fertilizers and deforestation. Now we need to look at the molecular mechanism by which greenhouse gases absorb infrared radiation. First of all, let's look at resonance. There's this thing called resonance which you should be familiar with. It will be addressed later in the syllabus. Most things have their own natural frequency, and these include molecules. They oscillate at a natural frequency. And these greenhouse gases, their natural frequency is the same frequency as infrared radiation. Now, molecules have vibrational and rotational frequencies. And if these molecules are subject to radiation which is the same frequency, in other words in the infrared, then that frequency will be absorbed by the molecules and will make them oscillate even more. So will start to resonate. When they start to oscillate and resonate, they become excited, and then basically they re-radiate this radiation. Now what happens to this radiation? Some of it gets emitted upwards into space, but some also gets re-emitted downwards. One misunderstanding of the greenhouse effect is that light which is reflected, or radiation which is reflected from the Earth, goes to the greenhouse gases in the atmosphere and is reflected back down. This is not the process. The process is that the radiation that is emitted from the Earth, which is in the infrared, is first absorbed by the molecules and then is re-emitted downwards towards the Earth. So effectively, the radiation is re-radiated back to Earth. It's not reflected, it is re-radiated. So this is one way of looking at it. We have blue light, or light of different frequencies, which is coming down to the Earth. This radiation then heats up the Earth, and then it gets reflected. And then it gets re-radiated at a longer wavelength. This happens to be in the infrared. Now, this doesn't manage to get through the atmosphere because this is the same frequency as the resonant frequency of the molecules that are in the atmosphere, of the methane, of the water, of the carbon dioxide. So then this is absorbed, and then some of this radiation is re-emitted down back to Earth. So these are the molecules which are absorbing this radiation. Some will be re-emitted that way, some will be re-emitted this way. So the light which lands on the Earth gets absorbed, gets re-radiated, not reflected, but re-radiated towards this molecule, and then that will be re-radiated back to the Earth again. So the more carbon dioxide, the more water and so on, the more greenhouse gases, the more of the radiation will be re-radiated back to Earth. So we have to look at absorption graphs to compare the relative effects of different greenhouse gases. Now you need to be familiar with the basic pattern, but the details you don't need to know. Now this is really interesting. This is the light that is landing on the Earth. This is the distribution of different frequencies against the intensity. This is the light that lands on the Earth. So it then heats up the Earth and then gets re-radiated. Now if you notice, there's only some of it gets re-radiated. This part here is completely missing. This here is completely missing. In other words, we don't manage to re-radiate this from our atmosphere. And why is that? Here we have a graph of the amount of absorption that takes place. Absorption and scattering. So let's look at, this is the part of the radiation which is re-emitted by the Earth because it's warm. This is completely absorbed, this radiation, by the atmosphere. So therefore we don't manage to emit this from the Earth. This doesn't leave the Earth. This is much better. There's not much absorption in these frequencies, but there's a great deal of absorption in these frequencies. So we're able to emit this radiation only, and there it is, but these parts of the spectrum we don't manage to emit. And why is that? Now we look at the different gases, how water absorbs different frequencies. It absorbs all the frequencies in this range, doesn't absorb this frequency, absorbs this one, doesn't absorb this one, and so on. So when the radiation passes through the water, this will be absorbed and this will be absorbed, but this won't. So this contributes to why the Earth's atmosphere absorbs this frequency and this frequency. Carbon dioxide is also a notable absorber of radiation. It absorbs a great deal in this part of the spectrum, which is in the infrared, and this part as well, and this part. Oxygen and ozone, they're also greenhouse gases. They absorb a little bit in this part of the spectrum. Methane is a little bit here and there, and so on. So in the end, the reason for our atmosphere absorbing these different frequencies is because each kind of gas absorbs a different range of frequencies. So the total addition of this absorption is here, and this is what is actually able to be emitted from the Earth, and all this part is absorbed. So the infrared is absorbed by these different greenhouse gases. So these part of the spectrum are missing.